Ladies and gentlemen, welcome back to the channel. For nearly a century, the titans of Detroit, Stuttgart, and Tokyo have sold us a comfortable, heavy, and incredibly profitable lie. Through billions of pounds in marketing, they conditioned the entire global market to believe that true safety, absolute vehicle control, and genuine off-road dominance could only be earned through decades of accumulated mechanical engineering. They convinced you that to conquer the basic physics of driving, you needed massive steel drive shafts, complex locking differentials, heavy transfer cases, and gears constantly bathed in thick oil. They sold you the 4x4 badge and the locked differential as the ultimate symbols of capability, training you to associate heavy, clunky metal with durability and superiority. And they lied. What Legacy Auto was actually selling you was the physical limitation of their own archaic engineering, a workaround for a problem they never learned to solve with code. Today, we are not looking at a new vehicle release or a simple facelift. We are dissecting a brutal industrial execution. We are going to break down the deep forensic engineering behind why the mechanical drivetrain has just been rendered structurally obsolete, and how Chinese quad motor architecture didn't just out-engineer the West, but mathematically eliminated the need for the drive shaft, the differential, and the transmission altogether. To understand the sheer magnitude of this disruption, we first have to look at the mechanical dinosaur currently sitting in your driveway. Since the invention of the internal combustion engine, the fundamental architecture of power delivery has stayed trapped inside rigid physical constraints. You generate power in the front or the center of the vehicle, and then you are forced to transmit that rotational force through a heavy spinning metal pipe, the drive shaft, all the way down to a central differential. That journey is an engineering nightmare. The energy travels from the engine, through the torque converter, through the transmission gears, down the drive shaft, into the transfer case, out to the differentials, and finally, through the axles to the wheels. At every single one of those mechanical connections, you suffer parasitic energy loss. Heat, friction, and rotational mass quietly steal your efficiency at every step of the chain. But the true fatal flaw is the differential itself. A mechanical differential, even the most advanced torsion or electronic limited slip unit fitted to a Range Rover or a Porsche, is by definition a reactive, dumb piece of heavy metal. It relies on physical binding, fluid dynamics, and clutch packs to guess which wheel is slipping and then attempt to redirect the power. It is a system permanently plagued by physical latency. By the time a traditional 4x4 system even realizes a tire is losing grip on black ice, sand, or deep mud, critical milliseconds have already passed. And in the world of high-speed vehicle dynamics, latency is the enemy. Those milliseconds are the exact difference between holding your trajectory and suffering a catastrophic loss of control. Legacy automakers spent a century and hundreds of billions refining this metal bending technology, constantly trying to slap software band-aids onto a fundamentally flawed mechanical system. Now enter the true paradigm shift of the 21st century. When Chinese engineers set out to build the ultimate dynamic platform, they didn't try to build a better, faster differential. They eliminated the differential entirely by moving the power source directly to the wheel hubs using 4 completely independent motors, a system fully realized in BYD's E4 architecture. They bypassed the physical limits of forged steel and stepped into the realm of pure, unadulterated software. Look at the raw hardware of this disruption. We are analyzing 4 completely independent, decentralized drive systems. There is no physical connection between the front wheels and the rear wheels. There is no physical axle connecting the left wheel to the right wheel. Each wheel carries its own dedicated high-performance motor and its own dedicated 800-volt silicon-carbide control unit. Because the power is delivered locally, right at the wheel, the system reaches a terrifying energy efficiency of over 97%. You completely eliminate the heavy steel shaft, the mechanical friction, the fluid maintenance, and the parasitic drag that has plagued Western vehicles for 100 years. But that raw efficiency is merely a byproduct. The truly weaponized advantage of decoupling the four wheels is absolute, instantaneous, granular control. Every single wheel becomes an independent vector of propulsion, capable of spinning at different speeds, in different directions, all at the same time, completely rewriting the physical limits of what a heavy chassis is even allowed to do. The definitive, undeniable proof of this is not found in slow rock crawling or parking lot party tricks. It is found in high-speed survival and emergency physics. Imagine driving a 3-ton luxury SUV down the motorway at 120 kilometers an hour. Without any warning, your front left tire suffers a catastrophic blowout. In a traditional Western vehicle, even the most expensive Mercedes G-Class or Ford Raptor, the massive, sudden, asymmetric drag instantly and violently rips the steering wheel out of your hands. The heavy mechanical differential and the standard electronic stability control are physically incapable of reacting fast enough to counter those forces. The vehicle pulls hard to the blown side, the mechanical grip limit is shattered, and the heavy chassis slides inevitably towards a lethal rollover. Now watch the exact same failure handled by independent quad-motor architecture. The millisecond the tire bursts, the central computing platform detects the sudden drop in rotational speed and the massive asymmetric drag. But it does not rely on brake pinching or mechanical gears to fix it. It uses mathematical torque vectoring. The system instantly fires massive positive and negative torque to the 3 remaining independent wheels at a staggering rate of 1,000 times per second. 1,000 individual calculations and micro-adjustments every single second. It digitally compensates for the collapsing posture of the vehicle, generating artificial yaw torque through the remaining motors to keep that heavy chassis tracking in a perfectly straight line. You can bring a heavy, compromised vehicle to a complete, controlled stop from motorway speed without ever once fighting the wheel. No mechanical gear, no clutch pack, and no physical differential in the history of engineering can react 1,000 times per second. This is no longer mechanical stability. This is software-defined invincibility. This level of dominance raises the ultimate, multi-trillion-pound question. If this decentralized and by software-driven technology is so vastly superior, safer, and more efficient, why doesn't Detroit, Munich, or Tokyo simply copy it? Why doesn't Legacy Auto just drop 4 independent motors into the next generation of their flagship trucks tomorrow? This is the innovator's dilemma currently paralyzing Western boardrooms. Legacy Auto is structurally and financially trapped by its own century of success. They have hundreds of billions in capital expenditure permanently tied up in a vast, complex global supply chain built explicitly to forge steel driveshafts, machine multi-speed gearboxes and cast heavy differentials. Their entire workforce, their union contracts, their patents and their enormous factory floors are all optimized for heavy metal production. Tier 1 suppliers like Magna, Dana, and BorgWarner depend on the continued existence of the physical drivetrain just to survive. To adopt a true decentralized quad-motor architecture, the West would effectively have to throw a century of mechanical superiority into the bin. They would have to close their foundries, let go of their mechanical engineers, and somehow transform into elite software and semiconductor companies overnight. They simply cannot adapt without cannibalizing their own hugely profitable, yet utterly outdated, mechanical infrastructure. While the West spent the last century mastering how to bend, cast, and lubricate steel, the Chinese industrial machine spent the last decade mastering the microchip, the high-voltage battery architecture, and the independent motor. We are not just looking at a cool new feature for off-roading. We are witnessing a brutal, unavoidable evolutionary leap in global industrial engineering. The era of mechanical compensation is over. The centralized engine is obsolete. The driveshaft is a heavy relic of the past. The physical differential is dead weight that belongs in a museum, not in a modern machine. The future of automotive dominance no longer belongs to the manufacturer that can cast the strongest steel or build the most complex oil-filled gearbox. The hardware is now merely a host for the software. The future belongs exclusively to the company that can process the maths the fastest and integrate it directly into the wheel hub. The traditional Volksnahe, gas-guzzling off-road legends of the West are walking the earth right now. Completely unaware that the software asteroid has already hit, thank you for watching. Don't forget to subscribe and hit the notification bell, because the engineering map of the world is being violently redrawn, and we're here to document every single millimeter of the collapse.